right, today we're going to do 9-3 and 9-4. All right, we've already talked about the fact that 9-3 is where we're going to spend the bulk of our time because we're going to be learning how to graph quadratic functions. Up to this point, we have graphed linear equations. Can someone tell me, if we were graphing a linear equation, what would the graph look like? Michelle? Your name's not Michelle, but that is correct. Okay, a line. Remember, linear equations, the graphs are lines. Now, we've been discussing for the last couple of weeks quadratic functions. Okay, and we've kind of already talked about this, but this is where you really need to start paying attention to the graph of a quadratic function. It is a U-shaped graph, and it is called a parabola. All right, so you need to make sure you learn the word parabola. Now, the U-shaped, you can see from the sketches on the screen, either your parabola is going to open up or your parabola is going to open down. And I'm going to teach you in this lesson how to tell if your parabola opens up or if it opens down. All right. Now, if we look at a parabola, if we break it down a little bit, these pieces that are labeled on this screen are very important. Okay. The first thing that you need to find when you're graphing a quadratic function is the vertex. All right. The vertex is either going to be the highest point on the graph or the lowest point. Now, that's going to depend on if the graph opens up or down. So you can tell from the screen, this parabola opens up, and so my vertex is down here. It's the lowest point of the graph. All right. If your vertex is not the lowest point on the graph, then you know you've plotted something incorrectly. All right. If my parabola was to open down, where would the vertex be? Would it be the highest point? Okay, or the lowest? It would definitely be the highest. All right, so that's your vertex. Now, the axis of symmetry is the next piece of information that is very important. What the axis of symmetry does is it splits your parabola right down the middle. All right, if you know what the word symmetrical means, it means that both sides of something are equal to each other. So that axis of symmetry is going to split that parabola right down the middle, and that's going to come in handy when we start plotting points. All right. If you've looked at your flow chart at all, the flow chart teaches you to come up with 7 ordered pairs in order to graph a parabola. I'm going to make you plot 3 points. Okay. Instead of 7, I'm going to ask you to plot 3. And 2 of those we're just going to mirror on the other side of our axis of symmetry. All right. So the axis of symmetry, very important, especially for us in the way that I teach you how to graph. All right. To find the axis of symmetry, and essentially to find the x-coordinate of our vertex, this is the formula that we're going to use. Does anyone recognize that formula?
No.
Okay, it doesn't look familiar to you at all?
Not at all. Not even
okay, all right.
It's the first part of the quadratic.
It is the first part of your quadratic formula. X equals negative b, and then it has the denominator of 2a. So this is the only formula that you're going to need when you're graphing quadratic functions. All right, when you're graphing parabolas, this is the only formula that you're going to need. Now, it's also important that you understand the correct form. All right, standard form. The x squared, the x, and the constant all have to be on the same side, set equal to either y or 0. Remember, y and 0 are interchangeable. All right, now, how do we know if our graph opens up or down? It's all about the leading coefficient. So if you're looking at a problem and it is in standard form, the leading coefficient is going to be the a, the coefficient of x squared. So I want everybody to add this to your notes. This is called a leading coefficient. Now, it's only leading because it's first. So if you're in charge of putting the problem in standard form, you've got to make sure that you've got your x squared, your x, and your constant in that order. It's the only way to guarantee that you have the correct leading coefficient. Now, if your a is positive, then your parabola is going to open up. And hopefully that makes perfect sense to you. If your leading coefficient is positive, your parabola opens up. If your leading coefficient is negative, your parabola opens down. All right? And then we've already talked about this, but to find the x value of the vertex and the axis of symmetry, we're going to use the formula x equals negative b over 2a. Very important. The axis of symmetry and the x coordinate of the vertex are the exact same number. All right? Now, let's start. We're not going to graph. We're not going to go all the way and graph yet, but let's talk about these main things and let's find these main pieces of information. All right, the first thing though I want you to do, let's go ahead and identify A and B. And you're going to notice I won't have you identify C because it's not in this problem. We just need A and B. So Kayla, what's the value of A? 5. And is that a positive 5 or a negative 5? Okay, so is my graph going to open up or down? It's going to open up. So right there, just by identifying A, I also can identify whether or not my graph opens up or down. And that's the first thing it wanted to know. All right, let's identify B. Ian, what's B equal? 10. Awesome. Now, once we've identified whether or not the graph opens up or down, they then want us to find the coordinates of the vertex and the axis of symmetry. Those two things kind of go hand in hand, so we're just going to work this out, these two pieces out together. So we're going to use the formula x equals negative b over 2a. Okay, write it down. So x equals negative. Remember to plug things in parentheses. What are we putting in place of b? 10. And in place of a? 2. Or, not 2. 5. Good. All right. So, am I bringing down a positive 10 or a negative 10?
Negative.
That's a negative over 10. So, what does x equal? Negative 1. Now, box it in. Why am I boxing it in? Because that is the equation of my axis of symmetry. So, you're not writing some big fancy equation, solving for x and telling me that x equals, in this case, negative 1, is you writing the equation for the axis of symmetry. Now, here's the next thing I like to do. Since the axis of symmetry is also the first coordinate of my vertex, I'm going to go ahead up here next to the equation. I'm going to put that negative 1 in parentheses. And now all I have left to find is the y coordinate of my vertex. How do you think we're going to find the y coordinate of your vertex? Plug it in to the original problem. So we're going to take y equals, and we're going to take 5 times negative 1 squared plus 10 times negative 1 plus 7. Now, order of operations says I have to do what first? Anybody? How am I going to solve that? Exponents. So negative 1 squared is what? Is positive 1. All right, let's bring down the rest of our problem. And now we can multiply. What's 5 times 1? 5 plus, what's, okay, so really we can just put negative 10. Bring down that plus 7. So what does y equal?
Y equals negative 3.
All right, what's 5 minus 10?
Negative 2.
Okay, listen to me. What's 5 minus 10?
Negative 5.
Negative 5 plus 7? Positive 2. And so I plug that into my ordered pair, and there is my vertex.
Wow.
All right, now this is not all of graphing, but this is the main bulk. If you don't even know how to start the problem, then you're going to be in trouble. So these are the steps to starting. Finding the x axis of symmetry, which in turn helps you find the x coordinate of your vertex, plug that into the problem, and find your y value for your vertex. All right, questions?
So there's more.
Well, yeah, we haven't graphed it yet. We're going to have to actually go graph it. Okay, but we'll look at that here in a second. Any questions on the axis of symmetry and the x coordinate of your vertex? All right. Now, let's look at the steps to graphing a quadratic function. Look at step 1 and 2. We've already done step 1 and 2. I've already taught you how to do it. You find the x coordinate of the vertex using x equals negative b over 2a. Then draw a dotted line to represent the axis of symmetry. Now, you're not going to see this on your flow chart, okay? And the reason, like I said before, the flow chart is going to teach you to find 7 ordered pairs. I'm only going to teach you how to find 2 and the vertex, all right? So 3 total, which means drawing the axis of symmetry is going to be very, very important to how we're going to graph these problems. All right, the second thing we're going to do, we're going to plug the x value back into the original problem to find the y value of the vertex. We've already done that. All right, this is where it gets new. We're then going to choose 2 x values to the right of the vertex. All right, so if our axis of symmetry is negative 1, we're going to pick 2 x values that go on the right side of negative 1. And we're going to plug those into the original equation and get us 2 more ordered pairs that we can plot. Step 4, we will mirror those points on the other side of the axis of symmetry. All right, so this is just for you to reference back to, all right, along with your flow chart that we're getting ready to look at. So on your flow chart, everybody go to your flow chart. At the top it says, look at your equation, and it's 0 equals x squared minus 2x minus 3. Is it set equal to 0? Class, yes or no? Yes, so follow the arrow to the left side of the paper where it says yes. Step number 2, we're going to identify A and B. All right, so read what is the value of A and what is the value of B. Awesome. All right. Then we follow to step 3. We're going to find the axis of symmetry by calculating x equals negative b over 2a. All right, so negative, Bruce, what's going in place of b? Negative 2, and what's going in place of a?
1.
Awesome. So am I bringing down a positive 2, Bruce, or a negative 2?
Positive.
Good, I got a double negative up there, so I bring down a positive 2 over another positive 2. So what does x equal? Class? 1. Good. Now, this is my axis of symmetry. So once we have that, we're supposed to go and draw a dotted line to represent it. So that's the first thing. Even though the flow chart doesn't do that, I want you to go down to that graph, and real quick, I just want you to draw a dotted line through 1. Okay, it goes from the top to the bottom. Again, it's important because of how we are going to graph. So we're just drawing a dotted line from the top of the graph to the bottom of the graph, and make sure it goes through your axis of symmetry, which is that positive 1. All right, now back to the flow chart. Once we have the axis of symmetry, it says replace the 0 in your equation with a y to find the related function. So for our problem, we simply have to replace the 0 with a y and then rewrite the original problem. X squared minus 2x minus 3. Now the reason it's doing that is because when we start plugging x values into the original problem, it wants us to realize that's how we're finding y. All right? Now step number 5 is where we're going to switch it up a little bit. On your flow chart, you're going to see there are 7 x value boxes and 7 y value boxes. Again, we're only going to fill in 3 of these. So the first thing I want you to do, I want you to go down to the shaded, okay, the middle. See the shaded area in the middle? In the x column, I want you to put a 1 there. All right, so we are making an x and y chart is what we're doing, and we've done this before. So our first x value is always going to be that axis of symmetry. Now, look, Mason, at your axis of symmetry. I need 2 x values to the right of 1. Keep it simple. What are 2 values that are on the right side of the 1 on the x-axis?
There's a lot of them.
Right, pick 2. What are the 2 that make the most sense right next to it?
2, 0.
2. All right, well, 2 works, but zero's to the left. So we need another number to the right,
Okay, yeah.
which would be what?
5.
Okay, go smaller.
4.
Remember, the bigger, go smaller.
3.
Good.
Okay,
2 and 3.
sorry, I didn't even look.
That's
at
okay.
it.
So literally pick the number, the next 2 numbers to the right of your axis of symmetry. It's going to make your life so much simpler. Could he have picked 4 and 5? Absolutely. We could have done 4 and 5. But our values would have been bigger, which means our graphs would have had to been bigger. So we're trying to keep our life simple here. So we're going to pick 2 values to the right of our axis of symmetry. Now, looking at step number 5, we're going to fill in this table, which means we have to take those 3 x values that we just chose and we have to plug them back into the original problem. Now, I realize your flow chart didn't give you enough room, so if you need to do it on your paper, that's fine. I'm going to do it down here at the bottom, but we are plugging in those values. So y equals, okay, 1 squared. I'm trying to do this so you guys can see what I've plugged in. All right, we're plugging a 1 in there. Minus 2, we're plugging another 1 in place of that x. And then minus 3. All right, so you see how we plugged the 1 into the original problem in place of x. Now, y equals, the second time through, we're plugging in a 2. minus 2 times 2 minus 3. All right, you guys with me? And then lastly, we're plugging in, we chose 3. So we're plugging in a 3 minus 2 times 3 minus 3. Now this is where your calculator comes in handy because we can do this math in our calculator. Now, according to our order of operations, what do we have to do first?
Exponent.
The exponent. So 1 squared is 1. What's 2 times 1? So what's 1 minus 2?
-1.
-1 minus 3. -4. So our first y value is -4. All right, do it with 2. 2 squared is 4 minus, what's 2 times 2?
4.
So 4 minus 4 is 0 minus 3 is awesome. And then 3 squared? 9 minus, what's 2 times 3?
6.
So 9 minus 6
3.
and 3 minus 3.
0.
0. Now, do you see how we have created 3 ordered pairs? All right, we have 3 ordered pairs. So now we're going to go to our graph and we're going to plot them. 1, -4. Your vertex should always fall on your axis of symmetry. Okay, it should always fall on your axis of symmetry. Then we have 2, -3. So we're going to go right 2 and down -3. And then, of course, 3, 0. We go right to 3 and we stay right there at 0. Now, this is where we're going to mirror, and you got to be careful. Right? Mirroring is not hard if you understand it. How many spaces away from the axis of symmetry is the point 2, -3? So everybody go down here and look at 2, -3. Okay? How many spaces away from the axis of symmetry is it? 1. So we're going to go to the left side of the axis of symmetry, just 1 space. Okay? So we're going to stay lined up with this point. We're going to go to the left side. We're going to go 1 space, and we're going to plot our point there. Okay? So that means that our point on the other side will be at 0, -3. Do you see how it's mirrored though? See how it's 1 space away? All right, this one was 1 space away from the axis, so we go 1 space to the left. All right, how many spaces away is the 3, 0?
2.
Be careful. Here's the axis, it's 1, 2 spaces. So we're going to go 1, 2 spaces to the left, which puts us at -1, 0. So that's how you mirror your points. Instead of having to plug 2 more values in and do all of this, we're just going to mirror it on the other side. Now, should this graph open up or down based on the leading coefficient? Go back to your A value. It's a +1. That's your leading coefficient. So does this graph open up or down? Up. Now, make sure it's a U shape. I know it's going to be real tempting to like connect the dots and make it a V shape, but it's not a V shape. All right, it is a U shape. So you want to come down here. You want to make it as U as you can, and of course your arrows are going to go on the ends. All right, but that is how you graph a parabola. Are there any questions? Because we're going to do one more here in a second. All right, let's look at letter B. Okay, if we follow the flow chart, okay, if we do what we did on the flow chart, first thing we're going to do, is it set equal to 0? Okay, no, but technically yes, because remember, y and 0 are interchangeable. So let's identify A and let's identify B. Gavin, Cameron, what is my A value this time? No? Right, the coefficient of x squared is -2. So A is -2. What is B, Gavin? Do we have an x term? So then what would our B value be? There's nothing there. 0. Good. All right. Now we follow x equals -b over 2a. So x equals negative, what's going in place of b? 0 over 2 times -2. So x equals 0 over. So what does x equal? Does it equal -4? 0 divided by anything is 0. So our axis of symmetry, everybody go on your coordinate plane, let's plot it. All right, it makes it a little difficult because it's actually on top of the y-axis this time. but that's okay. All right, we're still going to do that axis of symmetry because it's the only way to make sure we mirror stuff correctly. So if you have to draw a little darker, do whatever you got to do, but our axis of symmetry is actually the y-axis this time. All right, what's our next step? We've got our axis of symmetry. According to our flow chart, what are we supposed to do next? Anybody? Okay, let's make our own x and y chart. All right, what's the first x value that we've already found? 0. All right, and what are two values to the right of 0 that we can use? 1 and 2. Keep it simple. Okay, 1 and 2. So we're going to plug these values into the problem. So y equals -2. We're plugging in a 0. And we're going to square it. Y equals -2. We're going to plug a 1 in and square it. And then we're going to do a 2. And plug in a 2 and square it. All right, so order of operations says we do what first? Exponents. What's 0 squared? And 0 times -2? 0. Awesome. 1 squared is 1. 1 times -2. And 2 squared times -2. -8. All right, so we're going to plot our 3 ordered pairs. We have 0, 0, which again, that vertex. How do you know what your vertex is? It's the point that's on your axis of symmetry. All right, so if you're asked to graph and identify the vertex, which we actually were asked to do, so we're going to do that this time, we've got to make sure that we know which of our points is our vertex. It's always the highest point or the lowest point. All right, 1, -2, I go right 1 and down -2, and then 2 to the right and down to -8. All right, now Gavin Downing, if I want to mirror 1, -2, what are the coordinates going to be on the other side of the axis of symmetry?
-1, -2.
Very good. It's one space away on the right, so we're going to go one space away on the left and plot it right there. So at -1, -2. All right, Kayla, 2, -8. If we mirror 2, -8 on the other side, where's it going to be? How many spaces away is it on the right side? 2. So on the left, I'm going to go 2 spaces away, which is going to put it where? -2, -8. Very good. Does our graph open up or down? Down. It's a equals -2, so it's going to open down. So that's our last. We're going to make that U shape. We're going to put that arrow. And it did ask us to identify the vertex, so we're just going to label 0, 0. All right, your vertex should not be hard to find. It's either your highest point or your lowest point. Now again, it's up to you to memorize these steps. All right, it's up to you to remember how to plot a quadratic function. But are there any questions? All right. Now, lastly, you'll notice on your homework tonight, and let me throw this out there about your homework so I don't forget. All right. There are 4 graphing problems on tonight's homework. There's only 6 problems total, but there's 4 graphing problems. So that means you can do your homework on graph paper. So I want you to glue to your homework paper. I want you to glue a sheet of graph paper, fold it down the middle, work down the columns, but go ahead and work everything on the graph paper. That way it will be easy for you to draw those coordinate planes and graph those quadratic functions. Now, in lesson 9.4, we already talked about this, but it's solving quadratic equations algebraically. So algebraically is the key, because on number 34 on tonight's homework, you're asked to graph it and then check it algebraically. And yes, you need to check it algebraically. Before you panic though, this is something you've already learned, okay? Roots and x-intercepts are the exact same thing. The roots are the solutions to the quadratic function, and the roots are the x-intercepts. So they can use anything. They can say find the roots. They can say how many solutions are there. They can say give me the x-intercepts. No matter how they word it, you're finding the same thing. Where does this parabola cross the x-axis? So you learned this for your test last week. It's either going to have one solution, two solutions, or no solutions. So you can see from these sketches, okay, the parabola can cross the x-axis at two different spots, giving it two roots. It can cross the x-axis at one spot, giving it one root, or it can never touch the x-axis at all, which would give it no roots. All right? So this is something that you've already learned. So when we solve this algebraically, we are simply going to solve for x. What do we need to do first on letter A, Peyton, in order to begin to solve this algebraically? What do we have to do first? We got to get x, well, we got to get x squared by itself. So how are we going to do that? Good. We're going to divide both sides by 3. Awesome. So we've got x squared equals, what is 27 divided by 3? 9. All right. Now, Jacory, I've got x squared by itself, but I still need to get x alone. So how do I finish this problem?
Well, I wasn't paying attention. I'm sorry.
Okay. So how would I get x by itself? How do I solve for x?
Square root.
Okay, we're going to find the square root of both sides. Now, when we put the square root into the problem, what else do we have to put into the problem? Anybody, class? The plus and the minus. Remember, when we introduce the radical to the problem, we also introduce the plus or the minus symbol. So, what is the x squared, or the square root of x squared? Class? X. And then plus or minus, what is the square root of 9? 3. So how many roots does this problem have? 2. It has 2 answers. It has 2 x values, which means it has 2 roots, which means the graph would cross the x-axis at 2 different spots. It would cross it at 3, and it would cross it at -3. Okay? The main thing I'm trying to get you to understand right now is roots, solutions, and x-intercepts are all the same thing. All right? Now look at letter B. What would you do first, Mason, to get x squared by itself in letter B? Well, we want to get x squared by, we want to get this by itself. So what do we have to move first? What do we move first if we're trying to get that by itself?
Subtract 2.
Good. We're going to subtract 2 from both sides. All right. Now, Jordan, is x squared by itself yet?
No.
Jordan, how do we get x squared by itself? Divide by what? What's understood to be in front of that x? A 1. So we're going to divide both sides by -1. So x squared is going to equal 0. Now, how do we solve for x, Javion? Good. We're going to take the square root of both sides. And what also has to go in the problem? Plus or minus. What is the square root of x squared? And what is the square root of 0? Well, 0. Do I bring down, Tatiana, the plus or minus, though? No, there's no such thing as a -0. So my final answer is just x equals 0, which means, Tatiana, how many roots does this equation have? 1. Okay? It has 1 root. It is going to hit the x-axis at 0. So it is going to hit 1 time, giving it 1 root. Now, you say, why am I checking it algebraically? Because once you have number 34 specifically, once you have it graphed, let's say your graph hits the coordinate plane at 2 different spots, okay, on the x-axis. But when you solve it algebraically, it says it should only have 1 root. Then what have you done wrong? Okay, you've graphed it wrong. So that's why checking it algebraically is important, because you're going to be able to look back at your graph and you're going to be able to see if you graphed it correctly. All right, are there any questions on 9.3 and 9.4? Michelle?
So, how do we know if it has only 0?
Well, when you graph the parabola, it'll just be high or it'll just be low. It'll never touch the x-axis. All right, good job today. I will see you guys tomorrow.